This is a simplified version of the stair asset, which I'm going to use to set up the railings and the banister. To do this, I'm going to use the profile curve I made earlier, but I'm going to have to remove the points from the bottom corners of the stairs, and I'm also going to need to maintain the first and last points of the curve. I'm going to start by working on the straight version of the stairs, and then I'm going to do the bent version of the stairs later. I'm going to neaten up the graph a little by taking this null that I used to extract the geometry earlier and put it in line with the network. First, I'm going to use a group by range to extract the points which I no longer need from the L system. Now I will change it to points, and then I will remove the first and last points by changing start and end to 1. And then I will use the range filter to select every second point. And then I will shift the offset by 1 to make sure I'm selecting the correct points. Now I have all the correct points selected. And now I will rename the group. I'll use the $OS expression so that the group name will come off the node name. I'll then use the blast node to remove all the points which I've grouped. Next, I'm going to add a null to use as an output. I'll then merge it with the base. To do this, I will use a merge node, and I'll use an object merge to bring in the base. I then just clean things up a little and use the object merge to pull the L system in as well. I then create a null to reference the merged base as well. We will need to make the curve line up with the edge of the stairs. To do this, we will need to translate it by the same depth value that drives the extrusion. The next thing I do is I add an object merge node, and this is to pull in our new version of the profile. Now I place the transform node under the object merge node. I then use the depth parameter to drive the Z position of the profile curve. Because the stairs are centered along the x-axis, I will divide the depth value by 2. I then copy the transform node and negate the Z value. This gives me a profile on each side of the stairs. After adding the extrude nodes, I update the parameter interface. I do this to add depth and scale parameters for the sides of the stairs. I also create a switch node and use this to create a menu to allow you to decide whether or not you want to add stairs on the sides or on both sides at the same time. The newly created stair side parameter is now used to drive the distance value in the extrude node, and the extrusion mode needs to be changed to point normal in order to extrude in the correct direction. I then repeat the extrusion for the other side. This time I negate the value in order to make sure I then repeat the extrude for the other side. This time I negate the distance value in order to make it extrude the correct way. At this point I cap the sides. I also set up a transform to scale my profile curves. This was done using the centroid function. I chose, however, not to use this method, and that is why I'm using a time lapse to bypass this. Now I want to clean up the asset. At the moment I am repeating the same actions multiple times, particularly the scaling, which is currently being done twice. I do not want to have to scale things separately for the banisters. So in order to prevent this, I need to reorganize everything. To start to clean things up, I'm going to move the profile and make the entire profile separately of the generation of the stairs. I'm going to simplify the profile by only using the base from the bendable version of the stairs. The base is slightly more expensive than the version in the straight stairs, but this shouldn't be that much of a problem at the moment. I will start by copying the nodes that separate and resample the primitives on the base. Next, I copy the L systems and the base generation nodes. I add a merge node to reconnect the base primitives, and then I plug the original base into the blast nodes, as I no longer need the object merge node. Now I plug the L systems node into the banister profile nodes, and I remove their object merge node. The object merge node for the base is then removed, and I merge the side profile and the updated base profile. This final profile needs to be modified. I need to remove point 0 as I only want the point on the top of the stairs for this profile. In order to remove this point, I use a blast node. I set the group type to points, and then I set the group to point 0. Finally, I reconstruct the original stair profile and create a null to output that profile. I will now replace the original stair profile. I will get an object merge node, and I will reference the stair profile null, and then I can delete the old node setup. I can now simplify the other half of the graph, replacing it with the same object merge node. At this point, I could probably simplify this entire side of the graph into two nodes and integrate it into the other side of the graph, but I will leave it as it is for now. I need to be able to transform the profile curves for the sides of the stairs. I will need to scale them independently, so I'll give them both a transformation node. I will use the centroid function to scale the curves uniformly. Although over here I spell centroid incorrectly. Initially I tried to scale the second curve independently, but it should actually have the same centroid as the side profile. I now use the scale parameter to drive the uniform scale of these two transforms. Here I realize my error and make sure that the centroid is shared between both profiles. I can now remove the excess scale transforms from the sides. The scaling is not the only thing I can remove at this point. I do not have to have any of these operators twice. I can create the side of the stairs and then translate it by half the depth of the stairs plus the depth of the stair sides. Now I have a far more straightforward network for the stairs. In order to create the banisters, I'm going to use a very simple stand-in. First I'm going to add a geometry node, and then I'm going to add a box node. I'm going to move the base to a height of 0 by setting the y-center as a relative reference of the y translation and dividing that value by 2. I then set the x size to drive the z size, and then I scale this down and make it slightly smaller than the width of the side of the stairs. I will start the banisters by using an object merge node to bring in the simplified curve profile. I then copy the translation node to translate the curve to the side steps. This, however, is not sufficient, as I want this curve to align with the center of the side steps. To do this, I will need to add half of the value of the depth of the side steps to the translation in Z. I now have this curve centered along the side of the stairs. There are a couple of ways to handle the next part of this process. The most accurate way would be to loop over primitives with a for each primitive loop. I decided not to use this method, however, and instead start with a carve node. In the carve node, we will activate both the first U and second U values. These will allow us to control the first and last positions for the banisters. Then, in order to have more control of the number of struts, we will add a resample node. Using maximum segments will give a more even point distribution on the curve. We will then turn off maximum segment length, and in order to make sure that the curve retains its original profile, I will check resample by polygon edge. I now have an even point distribution for the vertical structs. Next, I will need a copy to points node. I will now want an object merge node, and I'm going to link this to my test geometry for the banister. I now merge these with the side steps. I could do this in a way which will give me more control, but it's not really necessary for what I'm doing with these steps at the moment. We use the detail profile curve again, and we transform it. We will transform it in the Y direction to place it atop the balustrades, and we will do this by using the bounding box function. I'm going to use the height of the test geometry, and I'm going to reference it from the object merge node. I rename it here in order to make it a little bit easier to find. And this will reference the dy max value. The curve is now at the right height, but I actually want to raise its height after I perform the initial transform. This way it will inherit the transforms and have the same x value as the original. I'll now form the ratings by sweeping a profile across this curve. Initially, I will use a simple grid, and I will convert this grid into a Bezier curve. I then use a sweep node to sweep the profile along the curve. Initially I forget to put normals on this curve, so I perform a couple of profile operations which actually were not necessary. I also made a copy of this curve which is offset in the y direction, which will allow me to give an up vector for these points. It's not 100% necessary in this case, but it is a good practice in any case. I now add the normals using the polyframe node. I then use sweep with auto closure and then just alter the parameters so that I get the stairs to be how I want them to be. I then use a polyfill node to fill in the ends and just a normal node in order to make sure the normals are all facing correctly. Finally, I merge it with the network, and now I have banisters for my stairs. I then just neaten up the graph a little bit. The final thing I do at this point is I make an object merge node, and this object merge node is going to be referencing the switch node for the banisters. I now use the merge node, and this is placed just before the bend node, and the banisters can now be merged with the bendable stairs.